Hi, welcome to Algebra 2 Common Core. Today we're going to expand on the process of completing the square in order to write a quadratic equation in vertex form. So let's start first of all with the form that we are going to be looking at. The vertex form of a parabola, so let's write it in our box, is equal to, well actually it's going to be y equals a multiplied by x minus h squared plus k. If we can rewrite our parabola from standard form, and remember that standard form is just going to be the form that we have been working with all along, y equals ax squared plus bx plus c. To convert it over to vertex form, then what we will be able to do is just look at our equation and tell what the vertex of our parabola is. So in this vertex form, the vertex is going to be the coordinates h, comma, k. So we'll be working with that form entirely in this lesson. But we want to begin our equations in standard form and rewrite them in vertex form. So let's start with exercise number 1. In the graph that we're given, we are given the graph of y equals x squared. That's our standard parabola graph. We want to be able to convert the equation y equals x squared minus 8x plus 18 over to vertex form. So I'm actually going to start writing part A right underneath my equation, just for lack of space underneath part A in my notes. I think you'll have enough room. So I'm going to start just like I did yesterday, and we're going to write down the steps in a little while at the bottom of your note page here. But step number 1 is going to be to move that constant over to the side of the equation with the y. So you'll notice that our first difference here between what we did yesterday and what we're doing today is to keep the y in the equation. We're not going to replace it with a 0 like we did when we were finding the roots. So I move the 18 over by subtracting it from both sides of the equation. Now my next step is to figure out what would be added to this right side to complete the square. So remember how we completed the square. I'm going to go off to the side here and say we're going to take half of the b term, so half of negative 8, and then we're going to square that. So of course half of negative 8 is negative 4, and then we'll square it. So that tells me that I want to add 16, but I want to add it to both sides of the equation. Whatever you do to one side, you have to do to the other side to preserve equality. Now when I do that on the left side, I'll be able to add together the like terms, so that'll give me y minus 2. On the right side, of course, this is now factorable. So our factors are going to be x minus 4, quantity squared. And again, remember the little tip I gave you yesterday. Whatever your half number is, that's the number that goes inside of your factor. Now this time, instead of solving for x, it's actually just one more step that I have to do. I'm going to take this 2 and I'm going to add it over to this side of the equation. So in vertex form, this equation is y equals x minus 4 squared plus 2. So what that tells me then, when I look very carefully at my vertex form in the box above, is that this number right here, the 4, is going to be my h, and the 2 is going to be my k. Now it's a little bit tricky. With the sign of h, I want to take the opposite of the factor sign here. With the k, I want to take exactly the same sign. So what this tells me is that my vertex is going to be the ordered pair 4, 2. So let's take a look at our graph for a minute. I want to move over. I want to go from a vertex of 0, 0. I want to count 1, 2, 3, 4 to the right and up 2. And I want to put my new vertex right here. For each and every point on my parabola, I'm going to do that same exact move. So I'm going to take this right-hand point and go 1, 2, 3, 4 to the right, up 2. I'm going to take this point right here And I'm going to go over 4 to the right and up 2. Let's do that for the points on the left side as well. So this point right here, over 4, up 2 brings me to this point. Now let's take this point right here and go 4 to the right, up 2, and I get this point right here. So I see that my whole parabola has been transformed to this parabola right here. So it's really helpful to be able to graph. I could take this equation, and when it's written in this vertex form, that means that I get this parabola without even looking at my graphing calculator. Now, of course, we could check that by going to our calculator and doing the graph of the original and seeing that it matches the graph of this. So for the description, what did we do to every point? We shifted every single point to the right 4 and up 2. And for part C in your question, just put in there that the vertex is equal to the ordered pair 4, 2. Now let's go ahead and write down what steps we just did. So my first step was to move the constant to the other side of the equation. So, in other words, it will be with the y or the f of x. And again, we're not eliminating the y or the f of x. This time we're keeping it in our equation. My second step is to divide out any GCF. This one didn't have one. On the x squared side. Now technically we're not going to divide both sides by that number. Instead we're going to keep it in the equation as a GCF. We'll see a couple examples of that on the next page. Step number 3 is going to be to find what the b over 2 is, so half of b, and then square it. And what do I want to do? I want to add that number to both sides of the equation. Step number 4 is to do the factoring of the trinomial. And step number 5, we're going to add an extra step in your box there. Get the y or the f of x by itself and identify the vertex. And our vertex is always going to be that h comma k. Oh, God. Now I'm actually going to skip our first practice because I don't like the way that I wrote the notes. So you could just put an X right over that first practice problem and go right ahead to practice number 2. So for practice number 2, I've got y equals x squared minus 6x minus 4. So I want to add 4 to both sides of the equation. Now you'll notice that this one does not have a coefficient of x squared, it's just a 1. So that means I'm going to skip step number 2 and I'm going to go right ahead to completing the square. So I'm going to take half of my middle number, which is negative 6. That gives me negative 3, and that's the number that's going to get squared and added to both sides. So I'm going to add 9 here and add 9 here. So the left side of my equation becomes y plus 13. The right side of my equation, I'm going to go ahead and factor as x minus 3 squared. To finish this off, we're going to subtract 13 from both sides of the equation. So in vertex form, this equation is y equals x minus 3 squared minus 13. So that tells me that the vertex is going to be the point. Now watch your signs. It's going to be positive 3, negative 13. So I take the opposite of the sign and I keep this sign for my h and k. What does this mean about my regular parabola? I'm going to shift 3 right and down 13. Let's go on to example number 3, because that one's going to be a little bit different. I'm still going to do my first step, so I'm going to move the 2 over to the left with f of x. So f of x plus 2 will be equal to 3x squared plus 12x. Now this example does have a coefficient in front of the x squared, so watch what we're going to do with this. F of x plus 2 is not going to be affected at all. But on the right side, I'm going to factor the GCF out of both of those terms. And in fact, it doesn't even have to be a GCF. It has to be whatever the coefficient of the x squared is. So I'm not taking an x out. I'm just taking out the number 3. So I've got x squared plus 4x left over. But I'm going to leave a spot where I will complete the square and add it in here. So let's take a minute to complete the square. We're going to take half of that middle term, half of the 4, and then square it. So that gives me 2 squared. So I'm going to add 4 to both sides of the equation. Well, before I do that, I've added 4 inside the blank, but really I've got to think about 4 being multiplied by this GCF, so I'm going to have to add 12 to this side of the equation. So 3 times 4 is really getting added to the right side, so I have to add it to the left side as well. So the left side will look like this. F of x plus 2 plus 12 is equal to 3 times x squared plus 4x plus 4. Let's go ahead and add together my like terms on the left. So f of x plus 14. On the right side, it's going to be 3 times x plus 2 squared. Last step, move that 14 over. So it's going to be 3 times x plus 2 squared minus 14. So that tells me that my vertex is the ordered pair -2, -14. Now this one does have that additional coefficient, which we'll be talking about in our transformation unit, but for now all we need to know is that my vertex is the new point -2, -14. So technically with this kind, when I have a number multiplied in front, I'm not going to just take my original parabola and move it 2 to the left and down 14. I'll have to consider this multiply by 3 as well. But in this unit, we just need to identify what our new vertex is. Let's look at example number 4 together. So I'm going to subtract 3 from both sides of the equation. And on the right side, I've got -2x squared plus 4x. Now, of course, I see on the right side that I'm going to divide out that -2 from both factors. So that's going to leave me with x squared minus 2x, and I'm going to want to fill something in to complete my square. So think about what we want to fill in. Take half of this term, half of -2 is -1. Square it, and that gives me a 1. So I'm adding 1 into that spot, but to figure out what gets added on the left side, I do this multiplication, and that's the trickiest part here. So I'm going to actually subtract 2 from the left side. So I now have f of x minus 5 equals -2 times x minus 1 squared. Add that 5 over to the other side, so f of x would be equal to -2 times x minus 1 squared plus 5. The vertex for this one, +1, +5. Let's do one more together. So I'm going to add 5 to the left. So that gives me 2x squared plus 16x on the right. Let's go ahead and factor out the 2. So I'm left with x squared plus 8x. Complete the square. So half of 8 is 4. 4 squared is 16. Now don't just add 16 to the left, multiply 2 times 16 and add 32 to the left side. So on the left side I now have y plus 37 is equal to 2 times, now let's think about the factors here. We're always using our half number, so it's going to be x plus 4 squared. And then go ahead and subtract 37 from both sides. So 2 times x plus 4 squared minus 37. Vertex on this one, -4, -37. That number got pretty big. Now I want you to try the you try it and identify the vertex when you're done, and then come back and check with my work. Take a look at my answer. In the first step I subtracted 10 from both sides, and I factored the 4 from the right side. Complete the square. So to complete the square I took half of 4, which is 2. 2 squared gave me a 4 right here. So I added 4 here, but then I multiplied to get the 16 on the left side. Adding together on the left side, that's y plus 6. Factor your trinomial, so that's x plus 2 times x plus 2, or x plus 2 squared. And then for the last step, move the 6 over to the right side of the equation, so that gives us a -6. Reading my vertex from here, I'm getting -2 for the x-coordinate, -6 for the y. Thanks very much for working with me today on vertex form. This is going to be a really important lesson for you to understand, so if you're having trouble, go back and watch some of the examples again. Have a great night.